Thanks, Caroline. It's horrible. It's nice to be back in Hobart, and thanks for inviting us down. I think last time I came on a Friday, it was a pretty long night, so that's your fault, Al. So hopefully I'll get home a bit earlier than last time. But yeah, it's just following on from Kathy. Again, under the Sense-T program, Tia's been chartered with leading the domain research under the beef and dairy livestock systems and optimisation of that. And that's a pretty wide scope type of topic, and I won't go into the detail about the data management, although I'll try to address your question a bit more, hopefully, Rowan, when we look at some examples of how it could be used. But hopefully today I'll just give you a good scope of what we've been doing and the processes that we've been trying to address, that we think some of the issues that the farmers currently face, particularly around as we grow to really large herd sizes. So I'm not sure if people are aware, but Tasmanian Dairy Industries has the largest herd size in the country, and that creates a fair few challenges, particularly around labour and also efficiencies in making decisions. And we think technology sort of kept pace with that in the sense that they've seen a lot of things that farmers need information and data flows for, and they've designed technologies to help. But what they haven't done really well is then say, how does they actually manage that information? And I'd like to finish the presentation about looking at data flows in dairy systems and how we can manage that, because a farmer can take their eye off the ball and spend all their time looking at data, and all of a sudden you've created another problem. So managing large herds is complicated, managing big data sets is complicated, and we've got to try to marry the two together in something that's a little bit more simplistic. So the objectives of the domain science area that certainly we've been working on. Hello, Barry. So sneak in. Predictions of pasture growth, one of those areas. So what we've done historically is done a fair bit of modelling, and a lot of our modelling's been looking back and saying how much pasture can we grow in a region, what's the water requirements in that region, what will happen under different management regimes and the like. What we haven't done with those modelling tools is look forward as a forecasting. And it's primarily for a couple of reasons. One, the tools were not originally designed for that. They were originally designed as research tools, so they will help us to address research questions and design research experiments associated with dairy systems, and never really designed to be an on-farm decision tool. So we think we've done a fair bit of work around parameterisation of these models, and I think it's time that we could actually make use of them out on farm. So things around looking forwards around how much pasture will I grow, but what will happen if I do X? So if I need to irrigate, and how much water I've got available, if I apply nitrogen or not, what will my growth rates be? And then feeds into decisions around feeding dairy cows. So will I need to purchase those supplements, or will I need to change my grazing rotation associated with the changes that have occurred with my pasture growth? Looking forward into the next 10 days, looking further out, hopefully out to 3 months, depending on our accuracy of forecasting. And then we looked at another area that we thought was quite critical, which was the management of larger herds. So average dairy farms pushing up around to close to 400 cows now. So that puts a lot of more emphasis on paid labour, and paid labour comes with challenges. So training, expertise, attention to detail. It's not like the husband and wife operation that's milking 100 or 150 cows and every cow's got its name, and you can tell if that cow's had a day off, which might mean she's sick, may mean she's coming on heat, may mean that you've got some sort of lameness. So we think behavioural monitoring as real scope. It's going to take some time though, because sensors on cows and analysing a lot of data and getting algorithms developed that allow us to say this is a grazing behaviour is challenging, and working really closely with the CSIRO guys on this, and there's some really exciting results to date, and I'll show some of them. So we think if we can determine that, we'll improve decisions around feeding, we'll improve our mating results and in-calf rates, and these will flow on to improve productivity, lower intervention costs, and just thrown in there, certainly lower our emissions associated with dairying, because we've improved efficiencies. We're not carrying as many poor producing cows or coal cows and the like. And then I just wanted to talk, like I said, just at the end, how do we make intuitive management decisions with our data knowledge? How do we handle that, and can we link it to certainly to input and output price scenarios? So I'll touch on the first area, which is the pasture growth forecasting area. So we've got 4 monitor sites, so similar to you, Kathy. Thought I had big enough ears, but maybe I don't. So we've got soil moisture sensors and automated weather stations across 4 sites, all in the northwest. A couple out on 2 of the VDL farms out near Cape Grim. So that's Woolnorth area. We've got one in the Flowerdale catchment and one in Mella. And we've installed these. There's nothing too robust about these, in the sense that we've got really good quality soil information flowing in, and climatic information, and we're doing regular pasture assessments, and we're trying to eliminate any factors that could influence that. So maintaining good soil fertility, exclusion obviously from the cows themselves, and we've also had to exclude some from wallabies in one of the sites. So a few challenges along the way, but we're getting good data flows coming in. So what's it look like, and what do we hope we will achieve? So you could take certainly historical information and live data feeds coming in from the region, and base that in a biophysical model. And I've just done a screenshot there of Dairy Mod, which is a fairly well developed and well parameterised model for particularly for the temperate dairying regions. And here on the screen you see that we get some predictions of what's happening with pastures. We've got our climate information coming in, we've got our soil related information, and these are, are more to do with paddocks and cow production. But the farmer doesn't want to use Dairy Mod, they don't want to turn that on, they don't want to be put off by that screen. Ideally what we'd like is that sits what I consider under the bonnet, and somewhere under the bonnet that runs at night and dumps itself into a hardware somewhere, and then that can be recalled from that source. So the farmer's out in the paddock, hopefully with an iPhone or an iPad and not a chunky Dell computers, but I thought that's what we have to carry around most times, so that's what it looks like. And then you just call up and you get this sort of information, a predictive growth of the probability. So we like to talk in risk factors. So just a probability graph there showing what's the likelihood of growth rate. So if you just read that along there, the chances of exceeding 20 kilos of dry matter is very low in the next 10-day period. Over here in the later period, achieving a growth rate of 40 reads at about a 30% probability. So they like to talk in those risk factors and base their decisions. What have we been doing with the sites that's already up and running? So we've done our soil information coming in and calibrated our soil descriptions, and we've got live sites with the weather information, soil characteristics, humidity, air temperature, soil temperature, all coming through, rainfall. So that can be viewed at the moment, and Greg Timms and his team's done a really good job helping us get that data into a format that we can work through and parameterise the models and start doing some testing. So yeah, similar to your weather stations, Kathy, it would have been nice if they put these poles here at about 7 foot instead of 6 foot. I wouldn't have had so many scabs on top of my head that day, but yeah. But yeah, we just go out and do these assessments. At the moment we're looking to parameterise 3 models. We're not just focused on the one. That's part of our science scope, is to certainly do a more detailed review of the models available. We're using Dairy Mod and also within the AppSim framework. And we're also at the moment trying to program an older model which is developed by McCall Bishop Hurley, which was done in New Zealand a fair while back. So we're looking at that because it's a little bit simpler and it might be easier for us to program into the future. So we're programming that in R. Well, when I say we, it's the collective we, but Matt Harrison's doing most of that work and doing a really good job with it. The things that we're looking to do, we parameterise things like the root distribution for those regions. We're looking at the fluxes of pasture movement through the sward, getting our calculations of evapotranspiration, making sure that we've described the soil and the properties of the soil, so the KSAT, the field capacity, wilting point and the like. And then we're just looking to make sure that any tinkering around things like the photosynthetic response, that we've parameterised that species for that region as best we can, and we're confident that any of the forecasting data is based on sound science. So I'll get to the acknowledgements, but this is some work that David Phelan done as part of some of the AppSim validation, which has come up really nicely. So we went through the parameters within there. The grey is the variation that we measured in pasture growth rate for the sites, and the dot's what we observed as a mean for those regions at that time, and this dotted black line is what we're actually currently happy with as far as our validation's gone. So obviously you only validate on the data you got, and you've got to make sure you're changing the right parameters, so we need to keep evaluating that for a period of time. We also need to extend it to other regions and check how it looks, but at this stage we think we've got a lot of the parameters well defined and we've got some confidence in the model. So we moved on to saying, can we run some technical analysis as opposed to just looking at a longer term 30 or 40 year run and saying, okay, in my region, in the average year, I'll grow 12 tonnes of pasture. We actually want to look and say, in the next 3 months, what's going to happen as far as pasture growth. And pasture is the key ingredient for dairy farming in Tasmania, cheapest source of feed, and probably makes up about 70% to 80% of an average cow's diet. So underpins our competitive advantage. So from my current position today, and this was done a while back, as most people know, that was a pretty horrendous end to spring and start to summer last year. And we actually did this for our research farm because we were making decisions about cull cows and do we actually dry off more cows than we need to? Was it worth purchasing feed? Will we come out of the horrendous feed gap that we were looking at? So at the end of February, we were sitting on growth rates of about 10 kilos of dry matter a day, and the model was picking that up. And we said, from that current position, if we got last year's weather, would we actually come out of it? And if we got last year's weather, it actually looked like it was going to be okay, you know. If we got March, April, May weather, we'd actually shoot up and we'd get there and we'd come out of it. But that, to me, seemed risky, just banking it on last year's data. So we had to look back further, and here's an example of 2001. And if we got 2001's weather, we're still going to be pretty much in real strife as far as our feed budget and demands go. So what we did with that, we ran a lot of years and made a tactical decision that we'll dry off early, and it was probably the right call. So that's what I call an historical approach to forecasting. That is, take all the historical years and just amend it to where we are now. So 22nd of November, if we're going to do a forecasting, look back at the 23rd of November, 1 year ago, 2 years ago, back to what we considered maybe 20 years ago is probably enough. And then, are those 20 years reflective of how we currently at? So we started to look at analogue years, years with weather patterns that are similar to what we're observing now. And so we've looked back and said, okay, we trust the data probably post-1960, and we pick out years that are in the same SOI phase, and away we go. And then we're looking at POAMA forecasts. So just to test the waters, here we've got July, August and September for this year. These were the forecasts that we ran. So we had an historical run. You can see that there's a probability here. Most people, I would imagine, would be familiar with box and whiskers plots, but that's where 50% of the variation exists. This is where with the average and the median. These are the more extremes. So we're thinking in July, with any of those forecasting approaches, we're going to be somewhere around about 16 to 18 kilos of dry matter. August, similar, and higher growth, but similar in their predictions across the 3 approaches that we're using, and also for September. So obviously those things have happened, those months have passed, and the dotted line is actually what we measured. So we're fairly comfortable that we're getting some level of predictions there that's not looking too bad. We're certainly within our box plots. Here we was really right on. Here it was at the higher level of the probability, and likewise here. So we've just done that again for October. I know that's past, haven't got the measured data in, but I know that's pretty close. And also November, which we'll come and measure in the next fortnight. And you can see that the 3 approaches to forecasting are very consistent early on, but then interestingly, when we look out in December, the SOI is suggesting that December could be pretty good for us, but the POAMA forecast is indicating that it's going to be a bit poor. So that will start to give us some level of indication of which of these forecasting approaches are most sound. So we're testing 3 models to see which model's the best for our forecasting, and we're testing 3 approaches for actually generating that forecast through climate information. So that's where we're at with that. I'll move on to grazing behaviour. I'm going for time. When did I start?
About another 10 minutes.
Okay, very good. So grazing behaviour, these are a couple of guys working with from Sorrow as well, from their livestock unit. This is Greg Bishop-Hurley and this is Dave Henry, so a couple of really good guys. They've done work with cow collars in more extensive regions, particularly working up in Queensland, where they use cow location and behaviour for other reasons, such as actually knowing where their cattle are, as opposed to a dairy farm where you go and see them twice a day. So we're looking at how we use the data that comes from these cow collars and what we can move from it. They're pretty chunky at the moment, but there's going to be a new and improved version rolling out soon. You see that they're around the cows here. around their neck. Under here is what's called an IMU, an inertial measurement unit, not too dissimilar to what's in your iPhone. So you've got accelerometers, magnetometers. We don't have a gyro in there. We've got a GPS unit on the back, and it picks up the planes of activity. And what we're trying to do with these cows is see the flow of information that comes from that inertial measurement unit in the cow collar and link it to actually with the behaviours that we've seen. So we went out in the field. Here we are watching a cow. It's probably the most relaxing day you can have in days at work, so quite enjoyed that. And if anyone ever is doing observational work, I suggest you get this app, which is called What I See, and you can just record what you see. So we put in the observations that we're looking for. It's good. Gee, this is horrible, isn't it? I've got to get a bigger set of ears. But anyway, what you do is you put in, so grazing, resting, ruminating, down the observations, and then you've got your subjects locked on the top, and you just enter, and it records at that time that it's doing it. And then when that changes, you just click there, and you've got the new observation, and it records, and all your data then just gets dumped into a CSV file. So throw away the pens and paper, much better. Throw away the data entry, much better. So really nice app, and I think it's only about $10 or $15. So yeah, it's good. But I suggest you get it on an iPad, not an iPhone, because. Yeah. Anyway, so what we do with that is we've observed those cows for quite some time, and what we was doing is doing them as 2-hour lots, and we had some cows that we put on 6 kilos of concentrates just deliberately, and some cows that we didn't feed any concentrates. So that means all their diet's made up of pastures, and the other cows are made up of 6 kilos, which is about it's a bit over a third of their diet. They probably get about 15-16 kilos, these cows in total. What you can see here is closed circles ruminating. So you can see during the morning session, that's when they just come out of the dairy, they have closed circles of grazing, sorry. When they come out of the dairy, they're grazing. And then in the afternoon, before the afternoon milking, they're laying down and doing a fair bit more ruminating. And then when they come back out of the dairy after the afternoon milking, they're back doing a bit more grazing. But you can see it's quite distinct here between those that are getting 6 kilos and those that are getting 0. So those that are getting 0 spend a lot more time, or a larger percentage of their time, grazing. And those cows that didn't get any grain at all in that morning session didn't spend a lot of time ruminating. So you can tell that management influences behaviour. But we're interested in, does the data that we get from the cow collars tell us what the behaviour is? Now this isn't my slides or done this work. Greg Timms and his team, Daniel Smith and other co-authors here from the CSIRO have done a fantastic job, and this data flow's just come through in the last few weeks. There's Greg and Dave from CSIRO as well, the guys you've seen before involved, and myself and James. But these are all the activities that we looked at, and they've clustered them. So they've taken the data that's come off the cow collars, and I think each cow collar is about 100 plus megabytes of data, and it's just in CSV format, so it's just text format. So they're massive realms of data that you just can't handle. Well, these guys can, but you know, us mere mortals certainly can't. And what you tend to see is that all these clusterings occur around different points. So grazing's highlighted here, searching, resting and walking, head down, ruminating, the like. So clusters representing those two things that, like ruminating and resting, were generally close together, because those behaviours are fairly distinct. Oh, not distinct, but close together in a sense. And then those that are more distinct, okay, resting and walking, we can certainly separate a little bit. So just did some cleaning up of that large data flow, and you can see that we can see those things there. So grazing over here, walking here, and resting there. So in general, most of the activities appear to be relatively well separated in terms of their activity class, and it suggests we could broadly classify these activities into what they're doing. So particularly those that are grazing versus those that are resting. Okay, so what do we plan to do with that information? If we can censor cows, we could actually relate behaviour to things that are important from a management point of view. And with large dairy farms, and on any dairy farm, mating and getting cows in calf is one of the underlying key performance indicators. If you've got a poor in-calf rate, a large calving spread, particularly for seasonal calving, it's a real issue. So what we're looking for is estrous detection efficiency, or ODE, and this is some work from Jenny Jago out of New Zealand. that showed that as ODE is improved, so the ability to detect an estrous event, so when a cow cycles and she comes on heat, our 6-week in-calf rate goes up. So you don't want cows having a really wide calving spread because you spend a lot of time calving and it's not ideal. So ideally, 75+% is a really nice result, and that's determined on getting 90+% ODE. So if you're relying on paid labour and you've got big herds and the guys are there smashing the cups on and the headphones on and not taking much notice, you're not going to get the estrus detection that you want. Likewise, you don't want a lot of empty cows after 6 weeks of that period because you're just going to cull those cows, and that's obviously costly. So if you can improve the ODE, okay, we can drop the number of empty cows, so empty being a non-pregnant cow. What are we doing with that? Hopefully a little bit longer and I'll be done, Caroline. The progesterone profile's there. Progesterone is the gold standard of estrus detection. So a cow cycles pretty much every 21 days. You can see here this is where it drops. So a cow approaching estrus will drop quite dramatically in progesterone level. And this is some work here from Walker and et al. And you can see that they've got a really nice progesterone profile. So we're working on some solid phase extraction to do that, and doing some work with the CSL, particularly with David Nichols, who's helping us out immensely and doing a great job. So we collect the samples, and we do it every 2 days for a 3-week period prior to mating, and then we're on every 3 days once mating starts, and we're nearly at the end of that. So it's been pretty intense measurements, getting these from the cows and then doing the extraction and then getting the samples sent down here. I dropped another lot of samples off this afternoon to David. So it goes through there, and down at the CSL they put it through the HPLC, and hopefully we get some nice results that we can then match up against the behavioural data. So just as a test run, who knows which cow's on heat? This one? This one? Anyone? Yeah? John, that one? Yeah? What about this one? Anyone? Yeah? Or this one? Okay. Yeah. Yeah, it's the cow underneath this cow. Okay, so what other ways can you detect it? These are scratchy pads. They're about $1 each. So no cow collars, no nothing. And they just light up when the cow gets what's called a standing heat. So she's standing there and the other cow notices that she's on heat and she jumps on the back. Okay, really an issue with managing lameness, by the way, but anyway, it's got to happen. These light up, and so when they come into the dairy you can see them, they stand out like beacons. You put a draft on them, you draft them off, and you inseminate them that night. So that's how mating works. Other guys use tail paints, but still it's relying on labour and detecting that. Okay. So what we're doing at the moment, collecting milk samples for progesterone. Here we've just separated them, put them through a centrifuge. Then we, in the lab, do the extraction, get our samples ready and send them down to David Nichols, and he's doing the progesterone profile. We'll match it up against behaviour, and we'll also compare the business as usual scratchies at how well they've been. So, which is what we use as part of our full herd operation. We've only got 40 of these collars, we don't have 340 of them. So we've put 340 on there. Okay, do you want me to keep going, or I can stop there? Because that's that work.
How long is it, the rest of your slides? How long have you got?
5 minutes.
Oh, do we want 5 minutes? Yeah? Go on.
You got somewhere to be, Al?
5 minutes. I've got something to do.
Okay, all right, so this is the digital homestead that Dave Henry and the CSIRO goes walk on up in Queensland. And they're creating a dashboard concept, particularly for beef, and we're saying, what have we got for dairy already? So the place where all information comes together, because you don't want to be having to deal with those big data sets all the time. Front page only, absolute critical bits of information, so farmers then look at that and say at a glance, what's my immediate decision? Is it a yes or no go? Do I need to make a decision? That's all they want to know when they get up and see the iPad or turn on the computer in the morning. Okay, a bit of information can then be interrogated and can be tailored to the individual's needs and preferences. So the characteristics, we want timelines, accuracy, and I think Kathy's covered them pretty good. So what's the digital homestead look like for beef? And it's online, and you can see where the cows are at the different times, and you've got external information flowing in. So some of those bits of information, particularly for these extensive operations, are waypoints, so you know which cows are meeting your market weight. Okay, they've got cow collars on, so they actually know where the cows are and their behaviour and things that they need to detect for. They've got other internal information such as on-site soil, moisture, weather information, the like. But you also need external information flows. So, forecast weather information coming in, cattle index for pricing. Okay, and here's some imagery of NDVI looking at potential pastures and production across the region. So that's what they're doing with the digital homestead, the Sorrow guys, and we're saying how can we adapt it to dairy? So from a dashboard concept, we collect a lot of information already, a lot more than you can get in extensive systems, livestock systems. And that's what I keep telling Brian. So we get like milk production data twice a day. We're measuring pasture growth on a weekly basis. We get milk quality information. We get live weight twice a day. So a lot of information already exists, and most people have to digest that, and that's difficult when you're under a lot of pressure and you think, how can I interrogate that data more simplistic? So we think there's a real role for a dashboard and an alert type system. Other things that we've already got on our research farm, we've got ideas about mapping is associated with our pasture covers, so which paddocks are bigger in terms of growth, so that might be about which paddocks get made for silage and skipped in the rotation, which paddocks aren't performing as well, so need nitrogen or watering. We've got live information associated with our climate coming through this weather station, and so we can look at soil temps at different times, we can look at humidity, rainfall forecast. We've got our soil moisture probes under our pivots, and we've got tools that allow us to look at, and this is called what's a feed wedge. So these are our paddocks ready for next grazing. So this is recently, we'll take those paddocks out for silage because we're above our requirements line. So things that are visible. Then we've got cow production flows. So from cow production, here you can see this is the herd average, what they've been doing. And obviously there was a spike there, which wasn't good. So we had a 1 day milking there. We had a vacuum pump blow up. So, and they're on 4 kilos a grain, so they only come in for 1 day in the dairy. So this is at a herd level, and then you come down to a cow level. So this is a cow's performance in the previous lactation, and this is this cow's performance this lactation. So that's where she's tracking. Over here again at a herd level, we've got days in milk along here, and we've got body weight slopes. So the cows get body weighed twice a day when they walk over our walkover scales. Here what we're looking for is cows' slopes that particularly are in the negative post 40 days. So generally when they calve they're going to lose body weight, okay? But as we're going into mating and cows are 40 plus days in milk, we want a lot more in the positive area, which means they're gaining weight. So we can look at that at a herd scatter graph, or we can again look at it as an average for a cow. So this is the cow's daily weight, and that's going to go up and down depending on has she had a drink on the way in, how much milk's in her udder, things like that. And we can do a 7-day average, which is much more powerful, and say, okay, how's that cow performing? Yep, she's tracking nicely, and now she's in that plane where she's putting condition back on. She should be cycling quite nicely for mating. So at a herd level for production, at a herd level for weight gain, at an individual level down here. So that pretty much covers it. So we'd like to get those things on the dashboard. Sense T and Tia's involvement's a fairly shared operation. Mark Freeman's doing a fair bit of work around the progesterone effort, and James is doing a lot around the cow collars. So James deploys the cow collars on the cows and downloads information and transfer and is doing the behavioural work. Mark's in charge of the progesterone testing and the scratchies. Matt Harris and Adam Langworthy and Dave Phelan all been involved with helping with the pasture forecasting and all the other people associated there. From a Sorrow perspective, particularly Greg Timms and his team from CSIRO have done a great amount of work with the data. Dave Henry and Greg Bishop-Hurley also with their engagement in getting us access to the collars. CSL Dave Nichols. All the dairy farmers that have been involved with the project, Paul Niven and Hugo from VDL, Lee Shuring from Mella and Nev Watkins from Flowerdale, and of course Sense T support, particularly Amanda Ros and everyone else at the program, Libby, John and whoever else is here. So that's me. Sorry I've gone a little bit over time.
That's fine. Probably we had some questions, etc. So we haven't really gone over time, and how wonderful to see such a team that you've got there, both stakeholders and people working in TR and people working in other research organisations. And I just hope that when you have a cow that's a high performer with all this technology, that the cow itself doesn't expect some kind of Gucci or diamond-studded collar to wear for a month and some kind of reward. Anyway.
They do. They take off when you first put the collars on.
Okay.
Yeah, they buck and kick, and yeah. But anyway,
So
settle down.
a couple of quick questions for Richard, and then we'll go upstairs and people can talk to him more. Okay.
Which I don't want to, again, renew that topic, but is my understanding correct that all the decision making is made on the climate parameters, essentially?
All the decision making is made on the climate parameters. Yeah. Okay. So you're talking about the pasture forecasting.
Yes,
Yeah. So at the moment, we have a fair bit of confidence, and we're very fortunate, particularly in Australia, to have access to the BOM data and through Silo, and it's pretty well accepted, although I think it does need testing. I know I did some work with Greg Holtz up there about that and the quality of it. I think we're fortunate that we got certainly better quality. We've looked at adapting the model in regions like South Africa and South America, and not to have that climate data as an issue. So that's part of the sense too, saying what is the quality of the data coming through. I think if the climate data that does flow in is good enough, then it's the model that sits there and drives it can give us a good forecast of pasture growth.
But reduction isn't too, like 50 years back or 100 years back, because you don't take into account genotype at all. I saw aerial photos of California with all the dry, so they have drought stress. So every pasture, every backyard is dry. They don't irrigate it because there is prohibition on using water, like restrictions like we have here. Soil moisture will show you no water, and at the same time a couple of lawns are just brilliantly green because they have the transgenic plants growing with cytokinase level. You don't take into account the genotype here. It's got no predicted value apart from the data where you measured it.
Yeah, I think, yes. Yeah, so we need as much validation across as many sites as we can, and you get acclimation of plants as well. So for us, we're parameterising particularly perennial ryegrass, which is our main temperate species that's used for feeding dairy cattle in our region. As we go further north, things like paspalum and the like need further parameterisation. So a lot of science needs to go in there, and I think that is underestimated, and that's why we're doing a lot of cuts, and also need to do the physiological measurements as well.
You need to put sensors really on plants, not in the air. I mean, air and soil is just conditional, but they're not responsible for everything. I mean, this is what a big mistake of all the climate models doing. I mean, they believe that they are things in themselves. It's wrong, just wrong.
But if we're able to measure those processes in the plants and parameterise them within the models, and the models cope with those processes, and this is where I talk to people like Ian Johnson who developed Dairy Mod, and he says, don't worry about the validation so much, make sure that the parameterisation of the model matches what is in reality at the site you're at, which is the soil description, which is the root distribution, which is its photosynthetic responses at different temperatures, which is its heat stress effects. And I don't think we've put enough work into when we do agronomic measurements, particularly when we're just measuring yields, to actually capturing those other measurements. And I think that's highlighted when we've come to do modelling. And we say, okay, and you've got to be careful with parameterisation, because when you parameterise, if you're changing the wrong parameter to get the right result, it's not good. So more sensors on plants to parameterise, but I think once you've developed the process and you've got confidence in that, you can use it. But I do agree, as you go to other sites, you need that level of detail to have the confidence. But that's, I think that's, as a needs basis for forecasting, I think farmers can make that call as we put the forecasters out. If it's not what they observe, they'll soon tap you on the shoulder and tell you it's not right.
It's also self-learning algorithms to calibrate to the local conditions. It's a machine learning sort of thing that in some models.
Okay, well, I'd like to thank both our speakers